We're going to start the first unit on characteristics of functions and properties in the first lesson 1.1. We'll start off with a little bit of grade 11 review, and then we will go on to section 1.1. So let's look through some important points that you may have learned in the previous grade. A function, in a function, you have a rule that associates one element of a set A to only one element of another set B. Set A is all the domain, and set B is all of the range for that function. A function cannot have more than one by y value for each x value. It can be tested on a graph with the vertical line test. So if you look at this graph of this line in blue, and the dotted line is being moved from left to right, and you would find that for every x value there is only one y value, so it passes the vertical line test. Whereas for this particular relation that you see over here, when you pass the dotted vertical line from left to right, you can see that there are so many values or so many points where an x value is having two y values that correspond to it. So it does not pass the vertical line test and therefore is not a function. You can represent a function in three ways: graphically by graphing on the Cartesian plane, or numerically by representing it as a set of ordered pairs, or with a table of values or a mapping diagram, or algebraically with the equation of the function. And keywords that we've learned is domain and range. The domain is set of all the x values in a relation, and the range is the set of all y values in a relation. So here are the questions that you would need to review, evaluate f of x for those values of x, and also some factoring questions. Now we are going to start with 1.1. Let's just look at these three examples. Let's try the first one. You're given a graph and you're asked to find or state the domain and range of each relation and explain whether the relation is a function. So if you look over here, the graph that you have in A, it is not a function as it does not pass the vertical line test. In B, you have a mapping diagram. So you can see that the x value corresponds to those y values. And it is a function because for every x value, there is only one y value. And you can see the ordered pairs here. Every x value has only one y value. And C, you have a relation given in an equation format, and you're asked to explain what is the domain and range and whether it's a function or not. So we can see that this is the reciprocal function. You have already seen this before. It passes the vertical line test. And if you were to graph it, you would get something that looks something like this. You have vertical and horizontal asymptotes. You will find that the domain of this function is x is a real number such that x is not equal to 0, and the range is y is a real number such that y is not equal to 0. And if you pass a vertical line from left to right, you'll find that for every x value there is only one y value, so it is a function. Let's review the types of functions that we have seen. The linear function, which is f of x equals x. The quadratic function, f of x equals x squared. The square root function, f of x equals root of x. The absolute value function, which is f of x equals absolute value of x. The reciprocal function, f of x equals 1 over x. And the sinusoidal functions, f of x equals sine x or f of x equals cos x. And you have to know how to sketch the graphs of these parent functions. Now, the next thing you have learned in the previous grade was also transformations of functions. So you can take a function f of x and apply transformations to it. So there's 4 key transformations that can happen that are represented by the a, k, d, and c values. A represents the vertical stretch of A, vertical stretch by a factor of A. And if A is negative, that means there is a reflection in the x-axis, which is also called a vertical reflection. K represents a horizontal stretch by a factor of 1 over K. So, and then D represents a horizontal translation of D units to the right. Um, and if D is greater than 0, it shifts to the right. If D is less than 0, it shifts to the left. C represents vertical translations. If C is greater than 0, that means it's translated that many units, or C units up. If C is less than 0, it has shifted C units down. And also for the K value, if it is negative, there is a reflection in the y-axis, which is also called a horizontal reflection. Okay, so you have to note that the K and the D values are they're tricky ones because they're kind of opposite of what they look like in the function. So this is K, that means it's a stretch value of 1 over K, or horizontal stretch. And if it's x minus d, then it's moved d units to the right. If it's x plus d, it's moved d units to the left. Okay, so here you have a function y is equal to f of x. It could be any function. Describe the function y equals 2 times f of 3x plus 6 minus 1. So if you look at this function, it doesn't matter which parent function it's modeling. It can be any parent function. But if you look at the way it's written right now here, the k and the d values are not clear. You have to factor the k out. There's some work involved here where you rewrite the function so that you can clearly see the k and the d values, which I've done here by factoring out the 3. So in the brackets goes x plus 2. So therefore, the a, k, d, and c values are 2, 3, negative 2, and negative 1. So because x plus 2, you write it in this form x minus d, so it becomes x minus of negative 2. And so you can see that there's a vertical stretch of 2 by a factor of 2. There's a horizontal stretch by a factor of 1 over 3. There's a horizontal translation of 2 units to the left, and a vertical translation of 1 unit down. So whenever you are describing the transformations, you have to say the stretch and by the factor. You also have to say if it is a translation, if it's vertical or horizontal, and how many units it has translated. Okay, so a second example here is y equals 1 over x. It's a reciprocal function. Describe the necessary transformations to obtain f of x equals negative 3 over x minus 1 minus 4, and you have to state the asymptotes. So you can see transformations have happened to this function. The a, k, d, and c values, you can see right away. The a value is negative 3, k is 1, d is 1, and c is negative 4. So there is a vertical, because of the negative 3, the negative value for a, there is a vertical reflection, or a reflection in the x-axis. Both of them mean the same thing. And because there is a value of 3 for a, the numerical part of it, there is a vertical stretch by a factor of 3. The k value is 1, so there is no need to mention anything about the horizontal stretch because it hasn't changed from it. It's still 1. There's a horizontal translation of 1 unit to the right and a vertical translation of 4 units down. And here you have f of x equals square root of x. Find the image equation after each transformation. They've described the transformations applied to the square root function in words. Reflection the x-axis, horizontal stretch by a factor of 3, and horizontal shift of 2 units to the left. Now I've written the function here after the transformations have been applied. So because there's a reflection of the x-axis, which is a vertical reflection, the a value is negative, and it becomes, it's positive 1 here, so it becomes negative 1. And under the square root, you show the horizontal changes or transformations. So because it has been stretched by a factor of 3, that means your k value is 1 over that 3, or 1/3, which you can see here. And because it has shifted to the left 2 units, it's x plus 2. And that has been described in words here, which you should do also just to kind of validate what you're doing to get to this answer here. So vertical reflection, or reflection of the x-axis, means the a value is negative, the k value is 1/3, and the d value is negative 2. Another example, decide whether the following relation is a function. State the domain and range. The function is y equals x squared. So we try to make a table of values for this function because it doesn't model a parent function that we know of. So we can just use a table of values where we go from, say, negative 3 to positive 3 and find out what the y values are that correspond to those values of x, and we see that this is what we get. You can see that because the x is squared in the denominator, no matter what value you give to x, when you square it, the y value always ends up being positive. So you can never have a y value that is negative. Whereas if x was 0, then you'd have 1 over 0 in the denominator, so you get an undefined value. But you can see how on either side of 0, they kind of repeat, okay? So what can we say about this table? It indicates that each number in the domain corresponds to only one number in the range, so therefore it is a function, which is what they asked us. And you have to also come up with the domain and the range. So what we can do is there is a vertical asymptote defined by x equals 0 because that's undefined. Its domain consists of all the real numbers except 0 because there's no meaning to assign a value of x to this function because the y value is undefined. So that means there is a vertical, it has a horizontal asymptote defined by the equation y equals 0. All its values are positive since x is squared, so they all lie above this line. So if you just take these this table of values and try to plot this function, you will get an idea of what the graph of this function looks like. And you will see that the y values will never be negative. So always be a positive. So y is always going to be greater than 0. And x cannot be 0 because the y value is undefined for x equals 0. Now you can try out the questions that are assigned